So in this video, we're going to look at how to prove properties about rational numbers. And again, because we're talking about any two rational numbers or any rational number, we cannot pick a specific rational number. And we have to use variables to represent any rational number. So the definition of a rational number is pretty much a fraction. So if you can write a number as a fraction, then it is a rational number. For example, say 1/2, that's a rational number. And 3 is also a rational number because we can write 3 as 3/1. And so pretty much all integers are rational numbers. But square root of 2, this is not a rational number because we can prove in later chapters, we can prove there's no way we can write a square root of 2 as a fraction. And so because a rational number is a fraction, how do we describe a fraction? Again, because it's not telling us which two fractions, it's just that any two fractions, and we have to use a over b to describe a fraction, because any fraction will be in this form. And make sure we know that a and b here are both integers, because if they're not integers, we may not get a fraction. Well, the reason we put b not equal to 0 because usually, we cannot divide an integer by 0. Okay, so the denominator is not a 0. Well, the reason we have to make sure they are integers is because you could have, say, if we have square root of 3 over square root of 2, well, the top is square root of 3, it's not an integer. And we get, this looks like a fraction, it's not really a fraction, because the top, it's not a rational number. This is not rational, it's still irrational. Even after we use algebra to simplify this, we get square root of 6/2. If you remember when you're learning algebra class, and as you can see, it's square root 6/2 is irrational. So that's why we have to make sure the top and the bottom, numerator and denominator, they are both integers. Okay, so we know how to describe any rational number now. We can use those forms to prove the sum of two rational numbers is rational. So because these two rational numbers, they are any two rational numbers, we cannot pick 1/2 and 2/3. We cannot pick numbers. We have to, we still pick two rational numbers, but not specific rational numbers. So what we're going to pick will be a over b and c over d. Let them be two rational numbers. Now notice that I picked different variables, c over d. So these two fractions, these two rational numbers, they don't have to be the same. They could be the same. If a equals c, b equals d, then they're equal. But they don't have to be equal. Let me specify, make sure a, b, c, d are all integers for this reason. And b and d, they are not equal to 0. Okay, so let's, next we want to translate words to symbols. So the sum means addition. So we are adding these two. So we got our first rational number a over b, and second rational number c over d. We're going to add them. And so here we're going to use algebra. We equal the denominators times d, times d, times b, times by b, and we get common denominator bd. And the top, we add the numerators, ad plus bc. And look, this answer looks like a fraction. Although top is kind of long, it is a fraction form because, we have the fraction sign here and the top and the bottom. Well, all we have left to check is to make sure this top is an integer and this bottom is also integer. Well, this is apparently true because we pick A, B, C, D, they are numerators, denominators of those two fractions, so they are integers. So we can write down a sentence to explain why they're integers. Since A, B, C, D are integers, A times D, integer times integer, plus B times C, integer times integer, will still be an integer. And of course, B times D is our integer because integer times integer. So therefore, we can say, AD plus BC over BD is rational because integer divided by integer, that's a fraction, that's a rational number.